Welcome to TMF2073 Intelligent System. This video is about autonomous vehicles brought to you by Amy, Josh, Chia Inn, and Vincent. First, let's look at the historical background of AV. In 1926, the first antecedent of AV called Lincoln Wonder was demonstrated. In 1939, the concept of AV was introduced at New York World's Fair. In 1950, the initial phase of research and development towards AV was jointly initiated by General Motors and Radio Corporation of America, called the Automated Highway System. In 1977, a Japanese professor named Sadayuki Sugawa built an AV capable of traveling at 20 miles per hour. In 1980s, the era started gaining footing in AV. The project called NAVLab, ALV, and Eureka. Between the year 2004 to 2005, the Grand Challenge program conducted by DARPA aims at moving AV through desert terrain. In 2007, the DARPA Urban Challenge focused on moving AV in urban scenarios. Since then, the R&D towards AV continued at a fast pace. Let's talk about the foundation concept of AV. There are several reasons behind the invention of AV. First is about the safety issue. As reported by World Health Organization, the annual traffic road death in December 2018 was 1.35 million, and most of it was caused by human mistake. Second is about mobility, so as the elders can get to anywhere without driving themselves. Third is about environment. It is believed that AV can reduce the emission of carbon dioxide. Let's take a look at the 6 levels of vehicle autonomy. At level 0, there are no autonomous features and everything has to be controlled manually. At level 1, these cars can handle one task at a time, like automatic braking. At level 2, these cars will have at least 2 automated functions. At level 3, these cars handle dynamic driving tasks but might still the intervention of human driver. At level 4, these cars are officially driverless in certain environments, and human intervention is optional. At level 5, these cars can operate entirely on their own without any driver presence. Next, let's take a look at the operation of autonomous vehicles. First is about computer vision. The autonomous vehicles must be equipped with exteroceptive and proprioceptive sensors such as cameras, radar, LiDAR, and ultrasonic sensors so as to enable the AV to see the environment. Second is about sensor fusion. It is the act of bringing together multiple heterogeneous sensors, and the AV can analyze the environment. Third, localization. The most common hardware installed is GPS, so the AV can know where exactly they are. 4. Path planning. The AV has to plan optimal path from point A to destination B to achieve the goal of cost-effective, energy-efficient, and minimizing congestion. Here comes to the most crucial part, control. The central computer processes all sensory inputs, plots a path, and sends the instruction to the vehicle's actuators, which control acceleration, braking, and steering. Last but not least, don't forget about the dedicated short-range communication. It enables the AV to communicate between vehicles, pedestrian, network, and infrastructure. Next, the 2020 Autonomous Vehicles Readiness Index. This index is measured between infrastructure, general consumer acceptance, policy and legislation, technology and innovation. The first country having to be most prepared for autonomous vehicles goes to the Netherlands. Next is the Singapore, and the third country goes to the Norway. Legislation and moral issues. First is about testing and deployment. The government should publish the code of practice, which set clear standards to be followed by responsible manufacturers, testing organizations, and test drivers. Second, licensing, registration, and certification. Manufacturers and other entities that produce Federal Motor Vehicle Safety Standard relevant products are required to submit identifying information and description form that lists the product of item produced. Third, data privacy and cybersecurity. They will have serious impact on information privacy of users if the information collected isn't handled with care. Fourth, insurance and liability. As there is a common question which asks, who should help the responsible for the accident? The AV? The human driver? Who knows? The future implications of AV. To prepare the deployment of AV, first, the roadway design. Because the AV is believed to be more safer, the roadway is allowed to be designed narrower. Second, modifying the infrastructure. As the AV can communicate between the infrastructure, so the infrastructure has to be modified and installed with intelligent systems such as the 5G. Third, special parking facilities. The parking facilities can be installed such as the cleaning and maintenance service. Fourth, as the deployment of AV encourages the shift from private to shared vehicles, this impacts directly to the public transit needs. And last but not least, the rules of the road should be changed according to the needs. And here comes to the end of the slide. I hope you do learn something from this video. Thank you.